Yes, hello everyone. Welcome to the second day of the session on artificial intelligence. So here the convener is Dr. Shubha, HOD, and the coordinator is Shushma ma'am, assistant professor. So yesterday we learned some information about the how artificial intelligence will work, and some applications also we have seen, right? Theory applications, and lastly I had given one demo. So today we are going to learn more about two applications. Starting. So fine. So today we are going to learn another two applications, how the artificial intelligence is going to work. Fine. So in that today's two applications, the first one is AI based object detection concept. Okay. So here in the entire world, we can take any object we can take, and we are able to detect that object information by using the artificial intelligence. Okay. So here how to take any object, any image, and how to train the data set, and how to work on that informations, what are the necessary things, everything we can discuss today. And next application is analyzing the data from information of diabetes. So by using the machine learning concepts. So what is the thing means here, whatever the reasons we are having to attack any diabetes, and based upon that whether the person is having diabetes or not. So we are having that data already. It is a supervised learning data set. So that data set just we are analyzing by using the machine learning concepts. So analyzing means just from that data frame we are going to plotting some values, and we are, by using the supervised algorithms in the machine learning concepts, we are going to predict the values from the data frame. Okay. So first let me go to the first application, that is AI based object detection concept. So just consider this one is an input image. Okay. So here we are having traffic lights and bus and one cycle, some person's information, and some truck also is there, right? So in our input image. So now whatever the objects is there in our input image, we are going to detect, and we are going to recognize that information. By recognizing it, it will give the matching points also. For example, the person is detected means how much percentage accurately it will give that classification result. That one result also we are going to predict. So here this is the output image actually. So if you observe this one, it is recognized as a truck, and the percentage is 90.12 percentage it is showing. Okay. So this one is about the matching point, whether it is a truck or not. So based upon that, here the matching points it is saying as 90 percentage it is matched as truck. Next bus information also. So here it is matched with the 90 percentage. So 93.92 the bus. Why? Because first of all it is not exactly a bus, minivan like that it will be there bus, but the information is less. If you observe, the information of this object is less. So in that case, how a machine also can detect that information if the object information, we are only giving the information is less. Okay. But if you observe here, there is a clear information about this vehicle. So it is detecting this as a perfect bus as 99.75 percentage. Okay, and remaining things also same here. This one is about the traffic lights information. It is matching up to the 57.34 percentage. So remaining things all about the persons. They matched according to 933 and 96, 99 percentage. Means AI is detecting this object's information. So this is our input image. So by segmenting that object's information, it is giving that labels classification. And this one by it will this is detecting this information also by cycle. Cycle has 59.12 percentage. So here, based upon the information what we are giving, based upon that it will work. Okay. So here if you observe first this one and this traffic light information also, particularly the example. So bus information we are having more clearly, right? So that it is detecting as 99 percentage. It is classifying the object by 99 percentage. But the traffic lights is it's not front end, it's like side view. Okay, so in that case it is detecting this as a traffic light with the 57 percentage. This one as a bus with the 93 percentage of information. Okay, so to do these things actually we need some modules, we require some modules, and along with that modules we need some database information also. Okay, so particularly in our programming we are using data set based upon the YOLO trained. Okay, so YOLO based trained data set we are using here. So what is the YOLO means? Actually, we are saying this one as you look only once. We are saying this thing as you look only once. Means whatever the object information we are giving, immediately by segmenting that information, it can predict the output. So here, for example, this is the image means first it will segment that information, images information. Okay, so in that segmentation again it will take one square box. So for this clearly dog information is there now. So this dog information it will take here, this many segments is there, the dog information. Okay, so it is separately segregated. Okay, with another one cycle is there. So cycle is having this many segmentations of information. Next, as well as in the background car. Next, any object is there means all the objects information it will separately it will do. So here finally the separated we are saying this one as this separate information as objects. Okay, so here this is not decided means which type of object, it is still no not classified. So we can say this one as counter detection. So by segmenting that images information, we are dividing into counter 1 and counter 2, 3 like that. So here to classify this objects information, we are using this data set. Okay, so in this YOLO data set, we are having all the objects information. It is a trained model. Okay, so it is a trained model which is with the weights information of all the objects information. So what is exactly weights means? We have to know little bit about the deep learning once again. So simply how a dog will look like. Okay, so how a cycle will look like. We are going to train a machine, or we are going to make one data set. It's a part of data science application. So we are going to prepare one data set with all that 1,000 or 2,000 or 1 lakh different types of features. For example, if we want to train our our own data, if we want to train means first of all we have to collect which data we have to train. So for example, dog if you take means, so if you want to create the data set, first we have to collect the dog data set with different features. Means by having the different features means with the different angles informations of the dog, and like front view, side view, and the entire back view, entire information. Minimum we will take thousands of images minimum. So by taking all those informations, we are training with the deep learning algorithms. So here in the object detection procedure, we will use the deep learning algorithms. So like that, by using the recurrent neural network and as well as convolutional neural network algorithms, This YOLO is already trained. You look only once. So this data set I am taking now. Based upon this data set information with that weights information, we are able to do the classification. Okay. So fine. So here this is the output information generally, and this is the data set information. And another thing, required modules. So these are all the required modules. First of all, TensorFlow, the version we need 2.4.0 and the Keras 2.4.3. NumPy version we need 1.19.3, Pillow 7.0.0, SkyPy and H55, Matplotlib and OpenCV, and the last, the important thing, Image AI. So here Image AI is having all these versions inbuilt. I am saying no need to install this Keras NumPy step by step once again. This Image AI, it is a separate module in the Python language which we can use to install this all packages at a time. Okay. So here by using this Image AI module information, we are installing all these separate modules information at a time. Okay. So here we may get some warnings because of this versions of module. If we want to avoid that warnings information, means better to choose the advanced versions more than this. Okay. So right now we included that advanced versions information only. So fine. So let me show you the coding first of all. So this is the entire code. This is the entire code to detect that any object information based upon the artificial intelligence. So first, whenever we are writing the code in the Python language, first we have to import the necessary packages. Okay. So here we need all these modules information. All these modules are the packages information we need. Okay. But instead of all these, we are using only Image AI. Okay. So from Image AI dot detection, import object detection. So from the particular module of Image AI, we are using that object detection information. Okay. So this one will help to detect the object. So afterwards, we are importing the OS. This one operating system, simply we will use to read the particular path information from our Windows. Okay. So first of all, I am getting the execution path os.getCwd, means it's nothing but where we stored our main program, means our source code where we stored. It will collect that data information. Data means the path information it will collect. So afterwards, here I am using the object detection, this particular module, and I'm going to store with a detector. Just a user variable I'm writing. Now, if you observe, we are using the module here, model here. We are using the model here. So here in this detector, object detection dot, I'm using set model type as. So whatever the trained model information we are taking here, that model information will be classified with this object detection in package. Okay. So it will merge this data set. Here we can use our required trained model. We are having this ResNet 50 Cocoa based H5 file and YOLO H5 file, and another one is there YOLO tiny H5 file. Okay. So these are all the different types of deep learning based trained models, weights information. Okay. So from these all, I am taking YOLO.h5 file. Why? Because this one is having more weights information. More weights information we are having. So that's why I'm preferred to take this trained model for the object detection process. Okay. Now whatever we imported in the artificial intelligence module, that module I am merging with the trained model of YOLO. Okay. So here whatever the classes we are having in this YOLO trained model, all those things we are setting to the model, to that model to the detector based upon the AI we imported. Na, that one we are trained model we are merging. Okay. So here again I'm saying we can take any model. If we are having our own custom trained model, that model also we can give as an input to the AI to detect the objects. So right now I'm taking YOLO one. Afterwards here detector dot set model path. This one is about to load the model, clear model information. Okay, so here I'm saying which type of model we are reading, YOLO based. Okay, so if we are using ResNet, here we have to use detector dot set model type as ResNet dot h5. Here ResNet we have to type. Here we have to give the model with respect to the path. So here we collected already where our code is saved, this .py extension file. So means in this py image AI we stored. Okay. So with that respective path, in that inbuilt path, we are having the model YOLO.h5, right? This one. So now that h5 model is going to dump in this detector. So without writing this line, if we are executing this line means, so here it will show there is no defined YOLO.h5 file. Means first we have to define which model we are going to give as an input to the AI. Okay, afterwards, after giving the name of that model, we are going to give that model information with the .h5 weights information. Okay, so afterwards, now we are able to load that entire model information by with the AI. The trained model information we are going to load with the AI. Detector means here we have to observe it's about the AI, image AI model. Fine. So after this, our own trained model by merging with the AI, giving as an input to the artificial intelligence. Now we are going to detecting the images. So this is our final output of detections from our input image. Just we are going to store with this name. So fine. Now how we are detecting means, so detector dot. Finally, detector means here not this detector, means what only object detection of AI. It's not like only of AI. We merged our trained model with that detector. Okay, so that detector information we are taking here, the loaded model information with AI, that information we are taking here. So based upon that AI model of YOLO, we are going to detect the object. So this one we are having here in this detector, we are having one inbuilt attribute. So it is nothing but detect objects from image. Okay. So first we have to give the input image where it is having the location, and that input image name we have to give first. So I'm taking input image as the inbuilt OS, the same directory I'm taking. So in this OS dot path. So here OS dot path means this one. This OS dot path where our file is stored. Okay, so on that particular thing, we are going to join our input image. Okay, so here wherever our coding is executing in that execution path, from that execution path itself, here we loaded now, that one we are taking, and in that path itself we are having one image dot jpeg. So this one. So here you can see image is the name and extension is jpeg. So this is our input image, original input image. Okay, so by giving this original input image to the object detector AI, we are getting our output image. So this is the entire, with a single line we are executing. So here output image path. So this is just a variable name. Actually this is the thing. os.path.join means we are going to save that output image. Okay, so we are going to save that output image. Okay, so in the same path where we given the input image, in the same directory. So here wherever we are giving our code, from that same path we are taking the input image. Okay, so from that we are getting the output image. So I'll delete and once again I will execute and I'll show you. So here you can see. So for the output image I am writing, I am giving the same path and I am joining the same path for the output image, and that output image will save with this name, image new. So the output image will stay with image new.jpg. Okay, so this is just about detecting the objects from the image, and we are giving the input image path and the output image path where we have to store by using this OS, right? So here we are having all the objects whatever it is detected. So detection means, remember, it will give the detection of the percentage and the class with the clear rectangular box. That is the output detections. Okay, now by taking this information, what we are doing means, just we are printing that each and every object name with the number of percentage probability. Okay, so here for each object in detections. So here in detections, how many objects we are having, we don't know. In our input image, around we are having like 10 to 12 objects. Okay, but when we change this input image name, any image we can take, any image in the entire world, any image we can take. Okay, so on that particular case we cannot fix how many objects is there in our input image. It will change according to the image, right? So and as a human we are also cannot fix that objects, how many objects is there. It will decide by the artificial intelligence. It is going to decide by the AI how many objects it is going to detect and how it is classifying and whatever the probabilities, everything is done by the AI only. So that's why here we are taking one for loop to identify the each object in the detections. Detections means about the output image. Okay, so by identifying each and every object, first and second, third, fourth, how many objects is there, that all the objects informations name, each object name and each object percentage probability we are going to print. Okay, so this is the simple coding processor to detect the objects in our input image based upon the AI. And I told you the required modules, right? So simply we can execute with single image AI module. So fine. So to execute this one, we are using the Anaconda navigator. So it is opening. Okay. So here in this Anaconda navigator distribution, we are having different types of frameworks. So in this, we are using the environment here. So in this environment, right now it is fixed with this base root environment. But to detect this object image AI based object detection, I have created my own environment. This one, image AI, I am AI. So to create any new environment, just we have to use this plus symbol here. And in that environment, whatever the modules we need, okay. So that modules information we are able to install. So to install, generally we have to right click here and click on open terminal. Okay, so the Anaconda will open with this separate our own environment. Okay, so here I had given that environment name as I am AI. Okay, so this is the default location. Whatever the modules we are going to install, it will store. Okay, but we are having our code in the another directory, right? In downloads by image AI. So we are having our data set and the input image and the coding in this particular directory. So on that case, just change the directory to our own paths. So just give cd change directory and our path information. So in the C drive itself, it will change the directory information to our own paths. Okay. Now, so here we are having our code with the main name with the main program. Okay, main dot extension will be .py. So I written that code in the IDLE usually, but for the execution purpose, I'm using the Anaconda Navigator. So why? Because in this Anaconda Navigator, we can avoid some unnecessary errors. So because of that, now we are using TensorFlow and Keras and NumPy and SkyPy. So many modules we are using, right? So here in this ideally we may get the versions problem whenever we are executing mostly. So to avoid that, we have to work a lot. We have to make changes over there. So for that, here I'm using that Anaconda Navigator separate environment, and this environment I installed particularly that image AI. Okay, so how to install that one means we can use pip command actually. So like pip space install space like image AI we have to use. Okay, so here I have installed already this one. So in that case, I can execute that directly. So that's why I have to install that AI packages and that particular TensorFlow versions and everything. I had created separate environment for this project. Fine. So now how to execute this program after changing the directory means just give here Python. So here we are going to execute the Python programming, right? So Python space which program we have to execute, we have to give that name and the extension. That's it. Okay, so if you observe here, I'm having another small program ID. This is just while execution of this program, just like a example purpose I written. This is not the code actually. So this is here we are having our main code. Just now I showed you now that 10 to 12 lines of code. That one we are having here. Okay, so the database and the input image, everything we are having, right? So just press enter. So here by loading that backend of TensorFlow and the Keras versions, by using that everything model of YOLO, it will do the classification of our input image. Okay, and after that you can see clearly here whatever the objects it is detected, that information here it's showing. It is detected one bus as 99.75 percentage and one truck with a 90 percentage, one traffic light information, bus and 4-5 persons and one bicycle, right? So here this is what the result. Fine. So now let me take one another image. So this one I collected like Indian traffic image. So how it will work, we will see right now. So fine. So here to execute this program, first we have to make changes in this code as an input image. So first this name is input and the extension is JPG. So input.jpg is the image name and extension. Okay. So here we can give like input, and the output image name also we can change. So here we can change out in. Okay, so just I changed the output image name to output.jpg. So fine, right? So now again I will execute this one. So here it will check our CPU condition also to work on these particular types of programs. Better we will take 4 GB RAM information. Okay, so definitely we need a Windows 10. Means I'm saying the OS or the architecture of the CPU will be some advanced. In that case only we can load that particular versions TensorFlow and Keras. Otherwise it will be very difficult. Okay, so by loading that entire information step by step, here you can see it is predicted this many objects, whatever the input image we had given right now. Okay, so car, it is detected at 10 or 15 cars with the percentage of 51 and 90 different things, and one person. Motorcycle, yeah, mostly these are the things we are having. Car, person and motorcycle is there. Well, I think we are having same thing in our input image also. And if you observe this object's information also not clearly. So here I will show you. So this information is somewhat clear, shapes particularly. Whenever we are using this object detection methodology, first the input image have to be clear. Clear means I am not saying HD, first the shapes information have to be clear. In that case only any AI or any information it can detect the object information. Well, we got the output for this input image. Now I changed the input image name to here, this one. So here this one is AI is detected like this. So like here person 52, this motorcycle is 866 percentage. It is this one is detected as car. Okay. So persons everywhere, motorcycle and cars information 51. So here we have to know one thing, why it is ignored this information, this particular information. For example, this information, it is ignored, right? Why? Because we can consider two things here. The first and the important thing, the information. We have to give the information properly. Okay, and if it is a combined thing also, it's not a problem. Means overlapping from one person to the another person also, it's okay. But the information have to be clear. In that case also, it is able to do the segregation. Why? Because we have seen the data set how it will work. First it will segment into some squares. Particular squares information it will consider as a labels. From that labels it will give the classification and the probability, right? So that much clearly the data set is trained. In that case no need to worry about that overlapping. The important thing is images information we have to give properly. That's the first important thing. Okay, and the second thing, sometimes the data set which we trained, it may give trouble. Trouble means it cannot classify that object information clearly because of overloaded weights information, maybe. Okay, So understood now this one, how AI based object detection is working. So once again I am saying these are the required modules to do, and these all the required modules we can execute by using a single command. Okay, so wait, that one also I'll tell you. After creating your own environment in the Anaconda, how to create means just use this create, and here by going to the environments. Okay, so here create your own environment, so you can give any name. So artificial, just I'm giving the name as artificial, and the Python version, which one you want to work, we have to select. So according to now the advanced one better to take 3.7. Okay, and if you want to work on the R programming, you can select this one also, right? So here I'm working on the Python 3.7 version. So here it is creating our new environment in Anaconda. Okay, so it's having 17.4 MB information. So after creating that new environment, so it will download that information. Right click on that and click on open terminal. So here by clicking that open terminal, we can write our installation procedure. So here we have to type that pip installation image AI. So I told you these are the required modules, right? So these all modules information. So without TensorFlow, we can install by using the image AI only. TensorFlow we have to install separately. It is a big package. So now it's created another one. So here in this environment, right click on that, click on open terminal, right? So here itself we can download that one. First of all, we have to select where is our code. So in this model we are having, right? In this particular path we are having our code, right? So whenever we want to install the code, we have to write main.python, sorry, python space main.py we have to write. But the module how to install means we have to use pip installation. So pip installation image AI, this is the default command. We have to use double hyphen upgrade. So for me, I have installed already, but here I am taking another version, right? Another environment. So what it will do means the required things, this entire informations it will download the particular modules, right? So OpenCV, SkyPy, Keras, and everything it is collecting and saying requirement already satisfied. Means I have installed already by using this command. Remember this one. So afterwards, so just we have to load our data set here. This one is a open source data set, YOLO based, but we have to know how to write the coding, right? So by writing that code, we are able to detect any image. So here, apart from this also, we can take any image which is having the objects. This artificial intelligence can give the output by detecting that objects information. Okay. So fine, this is about the first application, how we are able to work on that. So these are the outputs. Along with these predictions, we will save that image also, right? So let me go through the another one, another application. that is about diabetes prediction. So here to do this one, first of all, let me show you the output. So to work on that, I'm using actually Jupyter notebook. So I'm working on the Jupyter notebook for that. So here for the Jupyter, same thing. In Anaconda, go to the home and change your directory to base root. Why? Because here separate environments will be there now. So I'm going with the base root, and afterwards we have to launch the Jupyter notebook. So fine, this is the notebook. So here if you want to write a new coding, we can go here and we can take Jupyter new notebook. Here we can write whatever we want to write the coding. Okay. So fine, here I had written the code already to find out the diabetes prediction. So in this, the name is py will be there. So diabetes, and this one is our Jupyter notebook. We will say same Python coding only. Different in the Jupyter we are saying as IPython notebook. We can say IPYNB file. Okay. So by what we are doing means, first of all, we are analyzing that data frame information. That one we are saying as Excel sheet information, but we are going to save with the extension of .csv, comma separated value. Okay. So here, what is the machine learning concept here particularly means? So it is actually based upon the machine learning. So here machine learning we can divide into supervised and unsupervised and reinforcement learning methodologies. Based upon the working procedure, we are able to divide into this particular things. So by taking this CSV, we can apply the unsupervised learning algorithms. We can use the reinforcement learning. Now I'm using the supervised. Okay, fine. How to work on this and what is the advantage means? First of all, we have to know like these plottings methodologies we can do. So if we want to understand the data, so here this one is the data. So if you want to understand this data, overall data, so we are having 770 rows. Okay, and nearly 10 columns or 8 columns information is there. If you want to analyze this data and who is having the diabetes or not, this one is the outcome actually. So if we want to understand this information, it will be very difficult. But if we trained one machine properly, in that case, the machine can give whatever the information we need. We can get it easily. So now if you understand, just I want to know how many members are there with glucose and blood pressure. Okay, so with the percentage levels and with the number of patients, everything we can get easily when we are trying to understand that the data to the machine. So fine, so let me take this attributes values. These are the attributes values. This is our data set. So here based upon these attribute values, finally we will get one outcome as class like this 0 and 1. This is our data set. Okay. So here what is this attributes means? So whether the person is having the diabetes or not, is having or not. So to find out this particular information, compulsory we have to depend upon these attributes. Based upon these attributes only we have to know. So what are those attributes means? First we have to know whether the person is pregnant is there or not. Okay, or male or female, just we are finding. Okay, so if he is a male person, okay, if he is a female person, if she is having the pregnancy or not, we are finding out that, and that data set we are having here. Okay, Next, glucose level. So on that particular person, what is the glucose level we are having, and the blood pressure level we are having, BP, and what is the skin thickness, what is the insulin power, and next, body mass index. So this one we will collect from each and every what is that part of our body. Okay, so that one we are saying as body mass index overall, BMI information. Next, diabetes pedigree function. What is this one means? This one is actually about like family wise, some persons may attack age also, they may affected by the diabetes because their fathers having that diabetes, because of that thing, genes thing, we are able to get continuous that one. So that's why this pedigree function is about that one. Fine. So next, we have to collect that information also, that attribute also here. What are the chances we are having by that family interruption, genes based. And now another important thing, age. Okay, so age also we are calculating. So based upon all these things, the outcome class will be there. Another attribute, 1 or 0. 1 is means having, s, 0 means no, that's it. Okay, so these are the attributes we are having to find out that diabetes information of one person. And here, what is our output finally means, in the supervised learning methodology, we are trying to train that information to the machine. So now if you see, this is the entire result actually. So how many pregnancies is there? Okay, so that entire pregnancies is under, for example, I had said in our data set 750 rows information means 750 persons is there. So in that, how many members are having pregnancies, and all the pregnancies is understood clearly or not. So this one we are saying generally as heat map in the machine learning concept. This one we are indicating just to find out the accuracy level. So here minus 0.82 plus 0.8 is the accuracy levels. So here from our data set, that CSV file information, pregnancies as recognized as pregnancies as 80%. Okay, so here pregnancies information it is detected. Okay, so pregnancies as pregnancies. Next, whatever the glucose column is there, this one, this entire glucose column is understood by the machine as 80%. So here you can see these variations, this age. So some age column information is recognized as pregnancies, but this level will be very less, like 0.0 means 10 percentage information it is recognized like that, 5%. Okay, so by showing these color variations, we can here the heat map classification accuracy we can find out. Okay, so this is our final output in the application. Okay, so how to get that information, let me say step by step clearly. First of all, we are using these models to get that analysis of the data. First thing, pandas and numpy and matplot library and seaborn. So these are the required modules we need. First of all, coming to the pandas. So pandas is nothing but it's actually it is a data science module which we will use generally to read any particular information, any particular data frame. Data frame means like this Excel sheet and Word documents information, notepad information will be there, any text files, all those things to read and to convert that information into array values, we are using this pandas information. Okay, pandas. So I'm importing that pandas with a shortcut variable name PD. Next, numpy package. Numpy, or we can say numerical Python package. Okay, so this one we will use generally to create the array values, and from that creation of array values to do the calculations, compute to that array values, we will use this numpy package. Next, matplot lib dot pyplot as plt, this one. So this one nothing but matrix plotting library, we can say. Okay, matplot library lib. So this one we will use to plot this Excel sheets information in a statistical values like this, with a graphical representation simply. Okay, so here we are importing that one as plt. Next, cborn. Cborn means it is also about the plotting methodology only, but compared to this matplot lib, we are having some advanced graphics information in this cborn. Means in a better way we can show these results. So at the last we are having the result now, this information, this heat map generation, right? So how much the data it is understand clearly. That one we are generating this heat map by using this SNS. SNS means cborn only. Okay, fine. So this is the remaining coding procedure. First, by using the pandas, we are able to read that diabetes.csv Excel sheet information, this file. Okay, so we are able to read that information by using the pandas, and here this is our data frame. Okay, now I am using df.head. Head means it will describe, or sorry, it will show the output with 5 rows, initially 5 rows. Here we can change that information to the 20 also. So here we are executing the cell by cell program. Okay, so if we want to execute this line, so directly if we are executing means it will get error. Line by line, or we can say cell by cell only we can execute. Okay, so now if you see df.head I written, so head 20. So first 20 rows information it is printing. Okay, next df.describe. Describe means here it will find out overall entire rows average values, mean values. What is the total count? 768, right? So what is the mean value in that average value, and what is the minimum decimal value, and what is the 2575? This is about the description. What is the maximum value? So 75% these values are there. So in each and every row, we are having description. So just this one to understand the features information by the machine. Okay, so afterwards this is the information, whatever the columns information is there. In that non-null means without having zeros. So all the 768 rows information is having with integer 64. Nothing but all the 768 rows information having integers. There is no zeros. There is no null matrix. Understood my point now? So here this all 768 this Excel sheet having some information in each and every index everywhere. There is no empty shell, either 0 or 1, 0.8, any information is there. Means this one we are saying as feature extraction, pre-processing and the feature extraction we are saying. Okay, so this one is completely about the pre-processing, means analyzing the data information. Fine. So afterwards here we are going to do the feature extraction or plotting methodology by using that matplot library. So plt.hist. Hist nothing but we are saying this attribute as a histogram. Histogram of glucose and the blood pressure. First, from our data frame, I am calculating the entire glucose information. Glucose column information I am separately taking in H1, as well as blood pressure information I am separately taking. Now I am comparing the legend, means it's nothing but comparison glucose and BP, this one. Okay, and to plot that informations, we are using plt.hist of H1 comma H2, both we are plotting histogram. Histogram means like this, in bins format it will plot. Okay, and the colors also, orange is H1 glucose, green is H2 blood pressure. Okay, so we are writing the code now, so according to that we are getting that information. Okay, now we are going to get df.hist figure size 15 comma 15. So here 15 rows and columns information. We are going to use df.hist. df.hist means we are not defining any rows and columns information here. Overall entire data information we are plotting. Data frame information we are plotting histograms. So here we can see separately for age and body mass index, blood pressure, insulin, everything with the clear count information it is printing here. Okay, so this one is about the plotting again individual functions means individual informations like age and everything. So this is our final output. By plotting these differences information by matplot and SNS, here we are generating just a heat map, how it is classified that information. Fine. So this is how the machine learning will work for our data frames, any data frame. So fine. So these are the applications I want to discuss in today's our workshops. So if you are having any doubts or about the session, you can put comments in the comment box. Fine. So again, I have to thank these people, not only these people, who are all the persons involved in this workshop. All the persons I have to give the greetings. I have to thank them first of all. Fine. So thank you again, who are the participants joined in this workshop also.